we're asked to identify the slope and the intercepts of the equation y equals -9 minus 3x, and then draw an accurate graph of the equation. So the first thing to recognize here is that we have a linear equation that is in slope-intercept form, even though normally slope-intercept form is the form y equals mx plus b. Because addition is commutative, we can also write this as y equals b plus mx. The important thing to remember is b is the constant term, and b gives us the vertical intercept, and m is the coefficient of x, which gives us the slope. So the given equation is in the form y equals b plus mx. So comparing this form to the given equation, notice how this tells us that b equals -9, which means the vertical intercept would be the ordered pair 0, -9, and m, the slope, is equal to -3. So let's go ahead and enter the slope is -3. And now we do want to give the intercepts as ordered pairs. So we know the vertical intercept is the ordered pair 0, -9. Let's go ahead and plot this point on the vertical or y-axis, which would be this point here. Notice how any point on the vertical axis would have an x-coordinate of 0, and any point on the x-axis or horizontal axis would have a y-coordinate of 0. And therefore, to algebraically find the horizontal intercept, we set y equal to 0 and solve for x. So using the given equation of y equals -9 minus 3x, again, to find the horizontal intercept, which is the point where the line crosses the horizontal axis, we set y equal to 0 and solve for x. So we'd have 0 equals -9 minus 3x. Let's add 3x to both sides, which would give us 3x equals -9. Divide both sides by 3 to solve for x. So we have x equals -3, which means the x-intercept, which means a line crosses the x-axis or horizontal axis at x equals -3, which would be this point here. Notice how the ordered pair for this point is -3, 0. So we do enter -3, 0. And now because we have 2 points on the line, we do have enough information to graph the line passing through these 2 points, but let's find additional points using the slope. To use the slope to graph a line, though, we want the slope in fraction form. Let's write -3 as -3 over 1. Remember, the slope is equal to the ratio of the rise to run, or the ratio of the vertical change to horizontal change along the line. So because the slope is -3 over 1, from any point on the line, we can go down 3 units and right 1 unit to find more points on the line. So if we start the vertical intercept, this point here, if we go down 3 units and right 1 unit, this point must be on the given line. But let's actually use the slope to verify the horizontal intercept is correct. To do this, we want to find points to the left of this vertical intercept, which means we'll have to change the form of the slope. Instead of writing the slope as -3 over 1, let's write it as +3 over -1. Notice how the slope is still equal to -3, but in this form, the vertical change is +3 and the horizontal change is -1, which means we'd go up 3 and left 1. So from the vertical intercept, let's go up 3, left 1, which would give us this point on the line. And let's continue up 3, left 1 gives us this point. And then finally, if we do this again, up 3, left 1, notice how this does verify the horizontal intercept is correct. And now we know the graph of the given equation must pass through these points and would look something like this. I hope you found this helpful.